Welcome to Demystifying Math. In this lesson we're going to be comparing the geometric series to the harmonic series. A geometric series is one that has a constant ratio between the terms of the sequence and can be represented by the formula r to the n, where r is the constant ratio between the terms of the sequence. The geometric series will diverge if the absolute value of r is greater than or equal to 1. It will converge if the absolute value of r is less than 1. We can find the sum of the geometric sequence for an infinite number of terms by using the formula g over 1 minus r, where g is the first term of the sequence and r is the constant ratio between the terms of the sequence. Let's look at an example. 1/2 to the n would be a formula that would represent a geometric sequence. We want to find the sum of the terms of the sequence as n goes from 0 to infinity. Let's look at the terms of this sequence and the sum of those terms. So since we're starting at n equals 0, we have 1/2 to the 0, which is 1, giving us our first term in our sequence. We're going to add on the second term of the sequence, which would be 1/2, and then add on 1/4, and so on. So by using our formula for the sum of an infinite number of terms of a geometric sequence, we have 1 over 1 minus 1/2, or 2, which is the number that the series is going to converge to. Or in other words, it's going to be the sum of an infinite number of terms of the sequence. Looking at the list of partial sums that we have here, our first term is 1, the sum of our first two terms is 3/2. The sum of the first three terms, which is 1 plus 1/2 plus 1/4, gives us 7/4, and so on. Now the highest number that I listed there was 127 over 64. Well, that's very close to 2 already. If it was 128 over 64, it would be 2. So in a very few number of terms of our partial sums, you can see that we're really approaching 2 very quickly. Okay, let's look at the harmonic sequence. That's represented by the formula 1 over n. So the terms of the sequence would be 1, 1/2, 1/3, 1/4, and so on, starting with n equals 1. And then what we want to do is find the sum of those terms. And we're going to start at 1 for the harmonic sequence because it doesn't make sense to start this sequence at 0. But it gives us the terms 1 plus 1/2 plus 1/3, and so on. So we're going to take a look at the list of partial sums for this sequence as well. Now they're starting off the same. Both sequences, the geometric and the harmonic, have the first two terms of 1 and then 3/2 for their sums. But then it changes for the harmonic. Notice that when you look at the terms of the series in decimal form, that they tend to keep growing and growing, not approaching any specific number. Although they're growing very slow, they don't seem to be tapering off to any specific number. Let's go ahead and look at these two sequences on a graph. So this is the list of the sequence numbers for the geometric sequence 1/2 to the n. And you can see that pretty quickly those terms are heading towards 0. Let's look at the harmonic sequence of 1, 1/2, 1/3, and so on. Those are also heading towards 0, so they both have a limit of 0. But what you should notice is that geometric sequence is getting towards 0 very close, very quickly, and the harmonic sequence is heading towards 0, but not quite as fast as the geometric sequence. So they do both converge to 0. Now let's look at what happens with their sums. For the geometric sequence, we're starting off with 1 as well as with the harmonic. So let's do a representation of this using area. So both of those boxes will consider 1 square unit. Then for both of these series, we're going to add on a 1/2. So we have a 1/2 more. Now for the geometric, we're going to add on a 4th for the third term, and for the harmonic, we're going to add on a 1/3. So there's a little bit of difference there. Now with the geometric, we're going to add on an eighth for our next term, but with the harmonic, we're adding on a fourth. And what you should notice is that with the harmonic, we've already reached over 2. And we said the geometric was heading toward 2. So let's add on a few more terms here for the geometric. And you can see that we're just kind of closing in on 2, adding a smaller and smaller amount each time. So the geometric series is growing to 2, while the harmonic series seems to be growing off to infinity. So let's go ahead and look at a few more terms of the harmonic, just to make sure that it does look like it's going to go to infinity. So remember, we started off with a box, or our square that represents a unit of 1. Then we added on a little bit more. So I've added on the 1/2, the 1/3, and the 1/4. So those are the 4 rectangles that we have there. Now we're going to add on the next few terms all the way up to 1/12. And when we do that, you can see that I've got a little bit more than 1 that I'm adding on. And you can actually do this with all the terms of the harmonic. You can group them together and keep getting numbers that are greater than 1, slightly greater than 1. So if you keep adding on 1 and 1 and a little bit more than 1 and a little bit more than 1, your sum is going to just keep growing and growing and growing, going off to infinity. So although the harmonics series and the geometric series look very similar, with the harmonic series it's going to diverge, and with the geometric, if your ratio is between -1 and 1, it's going to converge. Thank you for tuning in. Feel free to contact me if you have any questions.